Imagine peering into the depths of space and uncovering a secret that challenges everything we thought we knew about the life cycles of stars. This is exactly what happened when an international team of astronomers using NASA's Hubble Space Telescope stumbled upon something extraordinary. An ultra-massive white dwarf star born not from the quiet death of a single star, but from the dramatic collision of two stellar bodies. It's a cosmic plot twist that reminds us how much there is still to learn about the universe. And Hubble has once again proven itself as the ultimate cosmic detective. At first glance, this white dwarf appeared to be just another ordinary remnant of a star that had reached the end of its life cycle. But here's where it gets fascinating. Thanks to Hubble's sensitive ultraviolet observations, researchers discovered that its past was anything but typical. Boris Gensica, the principal investigator of the Hubble program from the University of Warwick in the United Kingdom, explained, "This discovery highlights that things aren't always what they seem. What looked like a normal white dwarf turned out to have a wildly different history than we would have guessed." For those unfamiliar with white dwarfs, these are incredibly dense objects, roughly the size of Earth, but with masses comparable to our Sun. They represent the final evolutionary stage for stars that don't explode as supernova. In about 5 billion years, our own Sun will eventually become one of these stellar relics. While most white dwarfs weigh less than the Sun, some, known as ultra-massive white dwarfs, can tip the scales at up to 1.4 times the Sun's mass. These behemoths can form either through the natural aging process of a very large star or through a violent merger involving two stars, such as a white dwarf colliding with a companion star. What makes this discovery so groundbreaking is that it marks the first time scientists have identified a white dwarf created by such a collision based on its ultraviolet spectrum. Prior to this, only 6 similar merger remnants had been found, all detected via specific carbon signatures in their visible light spectra. All 7 of these unusual white dwarfs were flagged as being unusually blue for their age and mass during a 2019 study conducted with data from the European Space Agency's Gaia mission. This new finding adds critical details to the puzzle of how these mysterious objects come into existence. The star in question, named WD 0525 plus 526, lies approximately 128 light-years away and boasts a mass 20% greater than the Sun. At first, its visible light spectrum seemed unremarkable, resembling that of any standard white dwarf. However, when astronomers used Hubble's cosmic origin spectrograph to examine its ultraviolet signature, they uncovered something unexpected: traces of carbon in the star's atmosphere. Normally, white dwarfs formed from single stars exhibit atmospheres dominated by hydrogen and helium, with heavier elements like carbon locked deep within their cores. So why does WD 0525 plus 526 show signs of carbon? The answer points to a turbulent origin, a collision between two stars. When two stars merge, the intense heat and energy generated can strip away their outer layers of hydrogen and helium, exposing material from deeper inside. This allows carbon from the core to rise to the surface, making its presence detectable. And WD 0525 plus 526 isn't just any ultramassive white dwarf. It stands out even among its rare peers. With a scorching temperature of nearly 21,000 kelvins, about 37,000 degrees Fahrenheit, and a hefty mass of 1.2 solar masses, it surpasses the other known merger remnants in both heat and heft. But here's the twist that puzzled researchers. Despite its extreme temperature, WD 0525 plus 526 contains far less carbon in its atmosphere than expected, about 100,000 times less than other white dwarfs born from mergers. Cooler white dwarfs often mix carbon into their thin hydrogen-helium atmospheres through a process called convection. But this mechanism doesn't work for hotter stars like WD-0525 plus 526. Instead, the team proposed a subtler phenomenon called semi-convection, which allows tiny amounts of carbon to reach the surface. Without Hubble's unparalleled ability to capture ultraviolet light, detecting this faint signal would have been impossible. Hubble's cosmic origins spectrograph is the only tool capable of providing the high-quality ultraviolet spectroscopy needed to spot carbon in this white dwarf's atmosphere, said Snehalata Sahu, the lead author of the study from the University of Warwick. Her words underscore the indispensable role Hubble continues to play in advancing our understanding of the cosmos. And this is the part most people miss. WD-0525 plus 526 might not be alone. Its true nature was hidden until astronomers analyzed its ultraviolet spectrum, suggesting that other seemingly normal white dwarfs could also be hiding secrets of cosmic collisions. Antoine Bedrad, a co-leader of the study, expressed excitement about future research directions. We aim to investigate how common carbon-rich white dwarfs are and determine how many stellar mergers might be lurking undetected among the general population of white dwarfs. Understanding this could shed light on binary star systems and the pathways leading to supernova explosions. The implications of this discovery stretch beyond just one star. By studying these rare objects, scientists hope to refine models of stellar evolution and better predict the conditions under which certain types of supernova occur. Could there be more ultramassive white dwarfs waiting to be discovered? And if so, what else might they reveal about the dynamic processes shaping our universe? As Hubble enters its fourth decade of operation, it remains a cornerstone of astronomical exploration, consistently delivering insights that reshape our view of the cosmos. A collaborative effort between NASA and the European Space Agency, the telescope continues to inspire wonder and curiosity across the globe. To stay updated on Hubble's latest discoveries, visit https://science.nasa.gov/Hubble. So what do you think? Do you believe there are countless other stellar mysteries hiding in plain sight, waiting for the right tools to uncover them? Share your thoughts in the comments below. We'd love to hear your take.